Hey everyone, welcome to this Saturday bonus live stream. We're going to be talking about Ethereum 2.0, and all questions on today's live stream are going to be absolutely related to the topic at hand, Ethereum 2.0. So if you're curious about what this technology is and how it works, ask me questions in the Slido. The Slido code you can see in the screen that will pop up in just a few seconds, and we're going to start in just under 4 minutes. And before we start, I am going to tell you a bit about how I'm able to continue to do this work from a neutral perspective, without sponsors or endorsements, without advertising, under open licenses where all of this education is available free, ad-free, sponsor-free, and bias-free. And in order to do that, I rely on your support and donations. It takes quite a team, 12 people at the moment, to build these shows, to produce the content, to do all of the work that is required to make me honestly just look good and get my job done efficiently. And my entire team is supported by your financial donations, your subscriptions on Patreon, your YouTube memberships, and various other activities. So if you appreciate the work I'm doing, if you think I should continue providing education to as many people as possible, in as many languages as possible about Bitcoin and open blockchains and this technology space as a whole, from this non-biased perspective, and continue to provide that to you ad-free, for free, license-free, please consider supporting me. And I'm going to let some of the people who already support me tell you a bit about why they do that. While I thank everyone who makes it possible for me to do this work so much. I'm so grateful for all of your support. I'll be back in about 4 minutes, and we will go live with your questions. Don't forget to ask the questions on the Slido. And if you see a question that's similar to yours, vote that one up. Don't split the votes by asking it again in a slightly different way. Thank you, thank you, thank you, thank you, thank you, and thank you. All my patrons are the bee's knees. What on earth does that even mean? I don't understand. I think it's some kind of British expression. Who is this guy? What is he talking about? Do bees really have knees?
I am a patron of Andreas because I came across his videos online, and that's how I learned about Bitcoin, so that's how I got introduced to Bitcoin.
I'm out tonight at a social event organised by Andreas as part of his Patreon support. We just had a few drinks in a pub, which is a Punch Tavern, downtown London, so it's been a really fun evening to meet a lot of like-minded people.
We should support the work Andreas is doing. He's doing so much in getting new people into Bitcoin and into Bitcoin education.
He's a great teacher. He can explain very complex topics in an easy to understand way. He's very honest, very precise, technically prepared, and intellectually honest. I think is his best characteristic.
He brings such clarity to a really complex subject, which is Bitcoin, and the industry around it.
He has been a very, very good inspiration for me, and every Bitcoin I'm giving to him, it will be very well used in helping others understand Bitcoin, and I think it will improve the world at some point.
Being a patron, I get to meet Andreas, and that's why I love being a patron. I'm going to continue being a patron.
I think it's just a good thing. If you're interested in learning new things, and also want to support the Bitcoin community, then you got to be a patron.
Being a Patreon makes you feel special. You can attend to his live Q&A sessions. You can meet him at happy hours. It's really great, totally worth it. I'm very, very enthusiastic of being a Patreon.
I'd like him to be able to produce his great and valuable content in the future, free from advertising and just with the help of his Patreons, and that's why I'm supporting him on Patreon.
Hello and welcome on this beautiful Saturday morning, afternoon or evening, depending on where you are. Thank you so much for joining me today. I'm Andreas Antonopoulos, and I'll be answering your questions about the next iteration of Ethereum, Ethereum 2.0, the technical transition of Ethereum that is still in the earliest stages and exists only as a testnet today. We're going to be talking about the various phases of that. We're going to be talking about how that technology works, and I'll be answering your questions. Please submit them on the Slido. Also, if you want to chat about it in the chat, please keep it topical, and of course, keep it respectful and polite, and be kind to each other. I'll be dropping in the chat every now and then to chat with you, as well as perhaps looking for some follow-up questions, depending on how much time we can give to this. In the meantime, please do go on the Slido and ask your questions. I'll start with some very general questions, just so we can set the stage, clarify some of the terminology and some of the big picture stuff, and then we'll get into some more technical and more specific questions. So thank you for joining. We are currently streaming on YouTube, Twitch, and Facebook. Choose your platform. I'm mostly interacting with the YouTube chat. So if you're sending me live comments on Facebook or Twitch at the moment, I'm not able to view all of that at the same time. In order to do that, I need a battle station with lots of big screens over there, which I probably won't be able to read because I need reading glasses. It's a whole thing. So I'm just going to stick to YouTube. But you're welcome to watch me on any of the platforms that work for you, and I do jump into the comments afterwards. First question of the day comes from Tushai. Tushai asks, will you explain the major pieces of ETH 2.0? How is it different from the current ETH system? It's a basic question, but I have a day job. Can't keep up with crypto. Tushai, I feel you. I mean, I have a day job, and my day job is keeping up with crypto, and I can't keep up with crypto. Things move very, very fast, and the amount of work that is happening in terms of research as well as applied cryptography across this entire technology ecosystem is quite staggering. So let's look at the major pieces of Ethereum 2.0. So Ethereum 2.0 is fundamentally three major technology changes that are going to be applied, a transition program that starts with Ethereum 2.0 running in parallel with Ethereum 1.0, and then eventually with a migration of Ethereum 1.0 into Ethereum 2.0 in such a way that people currently using Ethereum don't need to change anything, and they will continue using it, only it will run inside Ethereum 2.0. It's a multi-year roadmap with several phases, and these phases are implementing three major pieces. So what are those? The first piece is a scaling technology called sharding. Sharding is where you effectively have a number of chains running in parallel. Each of these chains is called a shard. Think of it a bit like side chains, and these get synchronized to a master called a beacon chain, which coordinates between them. So sharding. Sharding is a scaling technology. Sharding allows Ethereum to immediately increase its throughput by a factor of 64, as in the original plan there will be 64 shards running. Think of each shard as equivalent to one current chain. In fact, that's exactly what will happen, because as part of this transition, Ethereum 1 itself will run in its entirety inside one of the shards. So one of the shards will become the continuation of Ethereum 1 inside Ethereum 2. So sharding. Sharding is the first component of Ethereum 2.0. The second major component of Ethereum 2.0 is proof of stake. So Ethereum 2.0 is a migration of Ethereum from a proof of work chain as it is today to a proof of stake chain. Now, Ethereum was always intended to be a proof of stake chain in the long term. That was part of its design philosophy. But it was implemented as a proof of work chain to start. Since its inception in 2015 until today, the first 5 years of Ethereum, proof of work. Over the next 2 years, Ethereum is going to transition into a pure proof of stake system with an intermediary phase, which is a hybrid phase, where Ethereum will exist as a hybrid proof of work and proof of stake system as part of Ethereum 2.0. So, sharding is the first technology. Proof of stake consensus algorithm is the second major component of Ethereum 2.0. And the third major component, which is still not entirely finalized, but is definitely part of the roadmap, is the transition of the Ethereum virtual machine to WebAssembly, or EWASM. EWASM. EWASM is a reimplementation of the Ethereum virtual machine based on the W3C standard of WebAssembly, which is used inside browsers as a native execution environment for assembled code that can run in a browser. What this does is essentially it allows Ethereum to share the toolchain and development skills of the future of the web inside Ethereum. What this means effectively is that you take your Solidity smart contract, and instead of compiling it to the EVM bytecode as it exists today, in the future it is envisioned that you will compile it to WebAssembly, EWASM, that will run inside a virtual machine as part of Ethereum's execution environment. So 3 technologies are part of the roadmap of Ethereum 2.0: sharding, proof of stake, and EWASM. Now, these 3 technologies are not being deployed simultaneously. In fact, there is a very detailed phase roadmap for which the first phases are pretty clear, and we're in the last stages before the launch of the first phase 0 of the ETH2 roadmap. But as you go further into the future, some of the later stages, specifically phase 2, are less clear at the moment. So the development of Ethereum 2.0 is a multi-year project. It's expected to take approximately 2 years from now to fully deploy through the 2 phases. So actually 4 phases: phase 0, phase 1, phase 1.5, and phase 2. And during this time, more research is being done, more testing is being done, and it's going to be deployed in this phased way so that that transition can go smoothly, and also because a lot of the details are not being finalized before the first phases are being deployed, so that research can continue. All right, that was the first question. Let's see, how did we do? I'm going to check in the chat and see how you're having so much fun right now. Perhaps too much fun. Maybe some of you are feeling a bit dizzy. Take a deep breath. This is a lot of fun, I understand, but let's not get too excited. All right. Let's see. Let's take the next question from Antonio Luna, who asks, what do you like about Ethereum 2.0? And I'm going to mix that up with a question I see on the chat at the moment, which is, why do you like Ethereum? This is a question I get asked all the time. And, you know, I understand that for some people this causes a fair degree of cognitive dissonance because they see that some of my opinions are well considered, that I have good answers for why I'm interested in certain technologies. They followed my work in Bitcoin. They understand what my vision in Bitcoin is. And then they see me exploring the technology of Ethereum, and this doesn't make sense. And I understand that. You know, it's not so easy to just dismiss this as, you know, a scammer or an idiot who's interested in this technology simply to enrich themselves, because I think I've demonstrated by now that that's not me. So some people are having difficulty with this. I'll be very honest with you. I totally understand this. I am interested in Ethereum because I think that the space of blockchains, especially open blockchains, is broader than just money. I'm interested in Ethereum because of the technology, but because also of the social and political impact of these technologies. I'm especially interested in the fact that Ethereum is much more an engine of governance than it is an engine of money. And I don't think the only application for this technology is money. Now, that doesn't mean that ETH is good money. And I think, in fact, for that application, Bitcoin is far superior. And for that, I'm going to get a lot of flack from the Ethereum space, who also don't understand why I still support the dinosaur obsolete chain of Bitcoin, which, of course, I do, very much so, and my work continues in that space. I'm not interested in Ethereum as an investment. I'm not recommending Ethereum as an investment. I don't know if it's a good investment. I never particularly cared about investments as the primary thesis. I am interested in Ethereum as a technology. And that may mean it's also a bad investment. I don't know. I don't care. That's not my decision to make. That's your decision to make. I'm interested in the technology because I believe, from actual study of this technology, you know, I did write this book, Mastering Ethereum, that this is a real technology, that it has depth, that it is meaningful, that it has vibrant innovation and research and development, and that people are doing very interesting things with it. Specifically, things you can't do with Bitcoin. Things you don't want to do with Bitcoin, because in order to add the level of flexibility required to do these things and to experiment in the domains of governance and smart contracts, you would have to weaken the security characteristics of Bitcoin, and I don't think that's a good idea. I think there is space for more than one solution set. And I think the technology is very, very real and very, very interesting. Does that mean it's going to succeed as an investment? No. Does that mean it's going to even succeed as a technology? No. But as an experimental research and technology testbed, it has already succeeded. It has succeeded by spawning hundreds of competitors and imitators that are trying to do the same thing. It has succeeded by spawning entire new application use cases. And from that perspective, I think it's very viable. And sure, a lot of fraud is being built on top of it. A lot of people are running scams using ERC20 tokens. Just like in the past, a lot of people tried to run scams based on altcoins that were clones of Bitcoin. A technology platform is not its application cases. A technology platform has value even if the majority of its application cases at first are scams. You have to decide which are and which are not, and how much you want to look at this as an investment versus a technology. Let's go to a technical question now, because I want to mix it up a bit. This is the kind of thing that may help illustrate the answer to the previous question, which is why am I interested in this technology. What is a ZK rollup? What are the advantages and limitations of it? Asks Niraj Badaya. Hi Niraj, thank you again for asking great questions. Some of my regulars on these live streams are a wealth of fantastic questions. Niraj is one of them. So let's go right into it. A ZK rollup is a mechanism that implements a layer 2 optimization on top of Ethereum that allows for compressing, aggregating, batching, we can use a variety of different words, or rolling up multiple Ethereum transactions into a single state transition that is submitted to the Ethereum state engine with a zero-knowledge proof. And what this allows you to do is to compress thousands of transactions into the space that you could only fit dozens of transactions, thereby increasing the capacity of the Ethereum system in some narrow and very specific applications, which today are primarily those of decentralized exchanges that are trading between various tokens that live inside Ethereum. So if you want to trade amongst different Ethereum-based tokens, rather than using on-chain transactions with high gas fees, you can use a relay function in order to submit your transaction in a compressed format to that relay function that takes that transaction, aggregates it with thousands or hundreds of thousands of other transactions, and produces a Merkle tree that expresses the entire sum of the state transition as one single state transition. That's a lot of words. Let me be a bit more specific. Ethereum doesn't use UTXO. It uses an account state system that tracks state transitions. It's essentially a function of the virtual machine that says, here's the state as it is now, here is a transaction, which is a transform. Apply the transform to the existing state and you get a new state. You start with state 0, you apply a transaction, you get state 1. Then you apply another transaction to state 1, you get state 2. You apply another transaction to that, you get state 3. So the Ethereum virtual machine is essentially a state machine that moves through states by the application of transactions. Transactions change the state, the global state of the Ethereum machine. Now that state may be the storage of a variable data, or it might be the change of the balance in an account. So a transaction may affect a change in balance, it may affect a change in the data store. And this is recorded as a change of state in the Merkle tree. Now, rather than submitting each of the transactions to the entire state of the Ethereum machine, what can be done with a rollup is taking the entirety of a state transition from multiple transactions. So say, take state 0, and instead of applying just one transaction to it, calculate the total change that will occur if 1,000 transactions are applied to that initial state, and then calculate a state 1 that is the rollup of all of the changes to the state from the application of all of those transactions. And instead of applying the transactions one at a time, you apply one rollup transition of the state, which can be done by a smart contract. And that transition is done in the form of a Merkle tree, where each one of the transactions and state changes or account changes that occur is a leaf on that Merkle tree, and the entire thing is rolled up as a single Merkle root. Now you can prove that the state transition occurred by looking for a specific leaf in that Merkle tree, and the entirety of the proof can be rolled up with a zero-knowledge proof, a ZK, zero-knowledge, rollup. And so that's what a ZK rollup is. It's a layer 2 technology for aggregating thousands of transactions and applying them as a single state change on the state of the Ethereum virtual machine in such a way that you submit a vastly smaller data set, but you still maintain a complete proof of the transition of state. Now the interesting thing about ZK rollups is that what we're seeing today is a narrow application of ZK rollups that are used primarily in decentralized exchanges. So you can take all of the transactions back and forth that exchange tokens and change the balance of various accounts in various tokens across an entire decentralized exchange. And instead of submitting each one of those as an on-chain transaction, you only submit the difference across all of those transactions. You may see some similarities when I talk about this. If you kind of understand what the Lightning Network does, this is not at all dissimilar from having an initial funding transaction, which sets an initial state of an account, lots of back and forth commitment transactions that are never submitted to the chain, and one final closing transaction that submits only the sum of the balances to the chain in order to massively increase the scale of Bitcoin. That's what the Lightning Network does. This is kind of the same, only instead of having separate payment channels, what you're doing is you're aggregating state across multiple participants. Kind of like a channel factory in Lightning. Now, zkrollup is one of many other categories of technologies that can be applied, and this broader space is called stateless Ethereum. And what stateless Ethereum is a move towards implementing Ethereum in such a way that the vast majority of the nodes that are verifying state are doing so by evaluating zero-knowledge proofs and the sum total of the state transitions without keeping the data of each transaction or state transition that is happening in the system. So you keep a snapshot of state and the state transitions through proofs, and you only evaluate the proofs. What that allows you to do is to have some nodes that are kind of like archival nodes that keep all of the data of the transitions between states and can be used by verifiers, validators, relays, and other nodes in the Ethereum system, especially those who are involved in consensus, as well as to bootstrap new nodes. But otherwise, the vast majority of nodes are simply evaluating proofs. So it's a lot broader than just ZK rollups. But ZK rollups are actually operating today. So you can use a ZK rollup as part of a decentralized exchange in order to get a much cheaper decentralized exchange trade between two tokens on Ethereum than if you were doing a one-on-one transaction. All right, let me take a quick sip of water. I'm seeing some deleted messages on the chat. Are people being naughty? Well, I'm going to mute, and then I'm going to put up the moderator rules while I drink some coffee and laugh and laugh and laugh at your attempts to be naughty with my moderators. I'm back. All right, let me very quickly tackle a follow-up question. What are some of the applications that I think can be done on Ethereum that can't be done on Bitcoin? Well, the implementation of zero-knowledge proofs as a roll-up mechanism is a perfect example of that. Can't do that. You can't move that fast in the development space. Bitcoin has to be more conservative in order to be sound money. Ethereum is willing to break shit. And, you know, that may make it a terrible investment. That's up to you to decide. But it certainly makes it a much more interesting development environment because things move very, very fast and a lot of experimentation can occur. Antonio asks, what do I need to do to start my own Ethereum 2.0 node now? That's a great question, Antonio. So where are we with Ethereum? Today, Ethereum 2.0 is running as a testnet for phase 0. Phase 0 is the first phase. And I'll talk about the phases in a bit more detail. I think there's a question about that. I'll try to dig it up and talk about the phases in more detail so I can roll out the roadmap so you can understand it better. But in summary, phase 0 is the beacon chain. Phase 0 is simply the proof of stake hybrid that is used for coordination. And what it is testing is the ability to stake 32 Ether and become a validator, with the goal that Ethereum has of having thousands of validators. In fact, for the initial stage, Ethereum is aiming to get 16,000 validators running on the Beacon chain. And testing the fundamental staking and validation function. The Beacon chain at the moment isn't processing transactions. In phase 0, it won't be processing transactions. In fact, the Beacon chain will never be processing transactions. The Beacon chain is for electing validators and coordinating between validators and giving out the rewards and penalties for the consensus mechanism around validators for the proof-of-stake system. The shards are where the transactions and smart contracts will exist, and those shards will be checkpointed, if you like, or synchronized to the Beacon chain. So where are we today? Phase 0 is operating as a testnet. It's an extension of the Gurley testnet, and it's called Medasha. Medasha, which is spelled M-E-D-A-L-L-A. There was a big argument about how you spell that and how you pronounce it. A lot of people thought it was spelled Medalla. Then some people pointed out that the double L in Spanish would be medalla. And then some people decided that the best pronunciation, I don't know what the consensus is, but I'm pretty sure it is this, that the double L is pronounced in the Argentinian pronunciation or South American pronunciation, Medasha, just like pollo and parisha. So that's the best of my Spanish. I'm sorry, I ran out. So Medasha, M-E-D-A-L-L-A, is the current testnet. And it's going to transition to another testnet called Spadina, which I think is imminent for version 12.3, if I'm not mistaken. I'm pulling these things out of my head, and I don't always remember the exact details. But if you want to participate in Ethereum 2.0 today, realize two things. First of all, it's a testnet. So what you're doing is you're using test Ethernet specifically, or test Ether, specifically Gurley test Ether. Gurley is one of the testnets of Ethereum, G-O-E-R-L-I, with an umlaut on top. So if you want to stake your Gurley Ether, you can do so in the Medasha current testnet, which is the testnet for phase 0, where you become a Beacon chain validator by staking 32 test Ether, and then participating in the consensus algorithm. What this allows you to do, fundamentally, is test out the software clients. I believe there are either 4 or 6 software clients, and I don't remember their names at the moment, that implement the Beacon chain validation for the Medasha testnet. By running these, you become familiar with how the software works. You become familiar with the rigors of the operational maintenance of a node that is participating actively in a proof-of-stake consensus. And there have been some problems already. In fact, there was a time synchronization bug or a overly strict dependency on network time synchronization in the Medasha testnet that caused a mass slashing event, which is the penalization of validators who went out of sync of the Medasha testnet. At least that's my understanding of it. So, you want that to happen with test Ether. You don't want your first experience with trying to maintain a node, keeping it up 24/7, monitoring it, being alerted when it goes down, finding out the bugs, running out of RAM on your server, running out of file descriptors on your server, running out of swap space on your server, finding a bug that crashes your system, etc., etc., etc. Now, you may think those are overly specific descriptions of specific things that might happen to your node. And I mention these because all of these things have happened to nodes that I'm running. Because this is the way of life in these systems. If you're running a Bitcoin node, if you're running a Lightning node, if you're running an Ether to Medasha testnet node, if you're running a Polkadot node, whatever kind of experimentation you're doing with these things, you will discover that keeping up a server and the service through maintenance, updates, and continuous 24/7 operation, which is required to maintain synchronization, is complex. it requires you to develop some sysadmin skills. And so you want to do that on a testnet. You don't want to do it with real money at stake yet. So what do you need to do to start your own ETH2 nodes now? You can go to the Ethereum Foundation's website, ethereum.org. You can find information on joining the Medasha testnet, downloading the client software, deploying it on a server, synchronizing with a chain, creating keys that will allow you to stake, and then putting testnet Ether against that and staking it and participating as a validator. What happens next is the beacon randomly selects from the active validators and has them propose and then validate blocks. And so you become part of that consensus. If it works for you, if you become good at it, when phase 0 launches, you will be able to move real Ether from the Ethereum 1 chain to the Ethereum 2 chain in a one-way function by depositing to a smart contract. Essentially, it's almost like an atomic swap between sidechains. And so once you do that, you can then take that real 32 Ether, put it in your validator, and start validating the beacon chain for Ethereum 2.0 phase 0, and you will get a portion of the reward. So after that, miners are not the only ones getting reward in Ether. Miners get reward in Ether on the ETH1 chain, while at the same time, it is being cross-validated in the beacon chain, in this hybrid proof-of-work, proof-of-stake, and validators staking their 32 Ether, which is the minimum stake you can put in, will be getting rewards in real Ether that is being recorded in the beacon chain. So this is an interesting experiment. Whether you want to go from the testnet to the real chain and put real money, that's entirely up to you. That depends on how much confidence you have in your technical skills of becoming a validator. But that's what you need to do to play with this testnet. All right, let's find some more questions here. Is everyone having fun? I hope so. I'm going to look at the chat as well. All right. Got about 400 people on the live streams just on YouTube right now. I'm hoping there are some more people on Facebook. I've heard that's a platform that is popular with certain demographics. I won't install that shit. And Twitch. So if you're enjoying it on those platforms, hello, welcome. Thank you all for participating today. I'm having a lot of fun. There's a lot of really great questions. I'm really trying to answer these with as much detail as possible, and these are not easy questions. It's a very complex space, and it does require a lot of analysis to form a cohesive and meaningful opinion in this stuff. By the way, this isn't in my book. Mastering Ethereum does not cover Ethereum 2. I'm waiting for phase 0 to launch. Once phase 0 launches and there is a much more clear path to phase 1.5, then I plan to actually release a second edition of Mastering Ethereum that will include all of the information that I'm able to learn and analyze and explain about Ethereum 2.0 and this transition. It's too early. I had the same problem with mastering Bitcoin, which was I couldn't really do the second edition until SegWit had been incorporated because it was such a significant change, and I had to wait. Okay, so we have a question from Mario. Privacy on Ethereum is a huge issue these days. Will there be more privacy on the base layer of ETH 2.0? Or at least better ways on how to achieve full privacy? Yes. Okay, let's start with the base assumption. Privacy on Ethereum is a huge issue these days. OMG, how true is that? Privacy on Ethereum is really quite a mess, honestly. In some ways, in other ways, there are some useful solutions. But one of the things that is very characteristic of Ethereum is that people have affinity to specific addresses. What that means is once people start using an Ethereum address, they connect that Ethereum address to a number of different services, and it is very convenient to keep reusing that address, and it is actually not that convenient to switch addresses. Unlike Bitcoin, where using a different address for every transaction is easy, with Ethereum this is not easy at all. So you will find that a lot of people use the same Ethereum address for everything they do. They connect it to the Ethereum name server service. They connect it to various DeFi protocols. They connect the same Ethereum address to exchanges. And as a result, that creates a very, very strong trail that is privacy breaking. However, Ethereum does have zero-knowledge proofs and the ability to do a number of things with zero-knowledge proofs such as rollups. And Ethereum has incorporated more and more cryptographic primitives in order to allow zero-knowledge protocols right into the main system. And this is the other benefit of Ethereum, which is that it can move faster on some technological innovations because it can afford or it is socially acceptable to break things in Ether. That is the fundamental trade-off. So yes, there are some future developments around zero-knowledge proofs. I'm not entirely sure about these details. I think one of the developments that is part of Phase 2, together with execution environments, stateless Ethereum, is also a new curve, BLS, which has some efficiency advantages, but also I believe is more conducive to zero-knowledge proofs. I'm not entirely sure. So there is a plan to make zero-knowledge protocols part of Ethereum in a much bigger way in order to solve the privacy issue. But that plan is at the tail end of this roadmap in Phase 2. It's not now. So will Ethereum 2.0 improve privacy? Probably. I hope so, and we'll see. I think that's the best answer I can give you on that one. Probably, I hope so, and we'll see. You know, sometimes you can't get direct answers. A question from Anonymous. What makes Ethereum 2.0 proof of stake different from other proof of stake systems? What are the types of network attacks associated with proof of stake and its solutions, if any? This is a very big topic, and honestly it's a difficult question to answer because I don't have that much depth of knowledge, especially with regards to other proof of stake systems, so I may get a few of the details wrong. But I'll give you my impression so far. Ethereum proof of stake is strategically different because from the initial design, the intention was to make Ethereum proof of stake much, much more decentralized than other proof of stake systems. And Ethereum proof of stake was effectively designed from the ground up. It's based on two parallel research threads called Casper, the friendly finality ghost, and Casper correct by construction, CBC and FFG. Casper, the ghost. And the name ghost comes from the greater, heaviest object state tree, or something like that, which is a protocol that Ethereum uses for its consensus algorithm. So, bottom line, Casper, as a system, was designed to address some of the problems that other proof-of-stake systems have had, and to really distill the fundamental principles or qualities that a proof-of-stake system should have. It's different in both its implementation and its strategic direction than other proof-of-stake systems, with a number of significant differences. The first one is, as far as I understand it right now, Casper is not a delegated proof-of-stake system. You cannot delegate your vote. So validators validate and they put their own ether at stake. You cannot ask someone else to validate for you and stake against them, from what I understand. Secondly, it's designed, as I said, to have lots of validators. 16,000 validators for the first phase, eventually reaching hundreds of thousands of validators, keeping the relative stake value low, massively decentralizing the function of validation, and assigning validators not through a voting mechanism, but through a random function. That's another pretty major innovation that was implemented for the Casper proof-of-stake system, which is the use of a random number decentralized autonomous organization, or RANDAO, and specifically a variable difficulty function RANDAO, or RANDAO VDF, which is a mechanism that is used in the beacon chain to randomly select validators to validate blocks in such a way as to expand the number of validators that can participate in the chain. And this randomness function is interesting and different from any that I've seen used anywhere else, because it is essentially it's a random number oracle that cannot be gamed because of the variable delay function. So those are two major differences with the proof-of-stake system. Another major difference with the proof-of-stake system is that many proof-of-stake systems out there have a reward mechanism, but they do not have a slashing mechanism. And the slashing mechanism is a mechanism whereby if you attempt to split your vote and vote for two chains simultaneously, or if you attempt to renege on your vote and go and vote for a different chain, hoping that history will be erased and therefore you won't face a penalty, slashing is a mechanism for committing to a chain many thousands of blocks in advance, and therefore paying a penalty where you lose some of your staked coins. So it's not just simply the time value of money that you're staking. It's not you put money in and it's locked and not accessible to you, so you'd better make some reward because otherwise you have this capital locked up that effectively isn't giving you any return. It's not just that. It is also that you can lose some of that stake. It can be slashed. That's another big difference from other proof-of-stake systems. Now, in the development of Casper proof-of-stake, two major research teams, one led by Vitalik Buterin, and the other one led by Vlad Zamfir. Vitalik Buterin formulated and designed Casper FFG, the Friendly Finality Ghost, which was a hybrid proof-of-work, proof-of-stake system that is being deployed as phase 0 and phase 1 of Ethereum 2.0. Vlad Zamfir formulated a pure proof-of-stake system called Casper Correct by Construction, and that is scheduled for a later phase when Ethereum switches to pure proof-of-stake. They have different characteristics, they had different research methodologies and goals. And interestingly enough, they were developed after an extensive review of the current literature and research done in other proof-of-stake chains, as well as other Byzantine fault-tolerant chains, Tendermint and other systems like that. What are the attacks? So the attacks associated with proof-of-stake, really there's two primary categories of attack. The first one is called the nothing at stake. problem, which is the idea that if you gain reward by voting for a correct block, you can just hedge your bets by voting for all blocks, and since only one survives, only one chain survives, whichever one survives you get rewarded for, and there's no loss in just voting for everything. That's called the nothing at stake problem, and it's solved with Casper by having a commitment that precedes your vote by several thousand blocks, and can be slashed if you attempt to split your vote and vote for more than one chains. So it will be noticed and your reward will be slashed, or your stake will be slashed. The other attack is called a long-range attack. And this is basically a trade-off, whereby if you solve the nothing at stake problem by having people commit several thousand blocks in advance, then the only way to attack is by going further back in the past, so that by the time you actually attack, you're reorganizing thousands of blocks in such a way that your stake can't be slashed because you simply went before you had submitted that stake. So that problem, a long-range attack, can be solved by basically checkpointing in the chain in a mechanism which is called social consensus, or subjectivity. And basically what this means is that clients that participate in this chain do not allow chain reorgs before or beyond a certain historical threshold. And in order to do that, they have to receive correct checkpoints from other nodes when they first bootstrap. This is a fundamental trade-off, a trade-off that Bitcoin does not make. In Bitcoin, you should be able to join the chain at any point in time, receive information from the Genesis block, and know you have the truth. In Ethereum, you have to find a trustworthy source in order to receive a checkpoint of a valid state. And in order to do that, you have to take some manual action to configure your client, meaning that you can be lied to if you do not have a properly configured client. And this is a trade-off in order to solve long-range attacks by requiring all of the clients to checkpoint at regular intervals every several thousand blocks and refuse to roll back, which means that you have to have some additional information. The chain itself is not the only piece of information you rely on in order to decide which is the correct chain. You also rely on information through other sources, the checkpoints effectively, that say, at this date, this was the chain that everybody agreed on. And that means you can't bootstrap without any external reference. You do have to have an external reference to prevent long-range attacks. And that's a trade-off that Ethereum is willing to make. The Bitcoin isn't. A very fundamental design difference. All right, let's see what else is going on here. What time is it? I'm having so much fun, I don't even know what time it is. Oh, 13 minutes to go. We're already 45 minutes in! Oh my God. Okay, people, I need to put my glasses on here. These are not fashion glasses to make me look more scholarly and professorial, serious. No, these are, I can't read without them glasses. Let's see what's happening in the chat. Are you having fun? Oh, we've got some great feedback here. Some people telling me that Casper FFG is not the friendly finality Ghost, but the friendly finality Gadget. Thank you so much. Got to get our acronyms correct. Also, Blockchain Bitcoin Ethereum is saying that Spadina is 10 days out. So that's the next testnet implementation, 10 days out from Medasha to Spadina. Mainvein asks, when staking, can you go offline without being penalized if you need to update your OS? I'm not sure. It depends on the chain. With some proof of stake chains, there's something called chilling, where basically what you can do is you can set a timer and say, I'm going to step away for a period of time, starting with a block, maybe several days out, and I'm not going to participate in that round. So your stake still remains in the network. You just remove yourself from the validator pool temporarily, and that allows you to do maintenance and not get penalized for being offline. I don't know if that is part of the Ethereum staking algorithm. Blockchain Bitcoin is also informing me that ETH2 Phase 0, this is with not testnet but real Ether, is going live in November. November 3rd? Just kidding. All right, let's see what else is happening. So much fun. My glasses are very 1960s NASA control room. Looking good. Houston, we have a problem. All right. Okay. Let's see what else we can answer from these questions. I'm going to go to the top again. Anonymous asks, why is Ethereum 2.0 and other updates taking so long and come with huge year-long delays with it? That's a great question. Let's see if I can answer this diplomatically but clearly. First of all, this is a very big update to Ethereum. 3 decisions were made. And these 3 decisions were made that delayed the implementation of proof of stake in Ethereum. If you've been following Ethereum, proof of stake was really scheduled for sometime in 2017. So it's now more than 3 years late. And that's because as Ethereum developed, as some of the scaling challenges became apparent, as some of the challenges with implementing scaling through sharding became apparent, as the proof of stake mechanism was fleshed out, people saw that there were lots of interconnected parts, meaning that in order to do proof of stake, you have to decide what exactly you are staking against. And if you are doing sharding, then what you're staking against isn't just the shard, it's also the coordination between the shards that happens on the beacon chain. And in order to do that, you have to decide how you're going to synchronize the shards with the beacon chain and enable slashing to prevent against long-range attacks. So this is one of those cases where innovations in one area and design decisions made in other areas started pulling in lots of related aspects of the protocol. It's a bit like tugging on a thread in a knit sweater and having the entire sweater unravel on you and turn into a ball of thread. Circular dependencies. In order to solve proof of stake, you have to solve sharding. In order to solve sharding, you have to solve proof of stake. And in order to solve both, you have to decide on slashing. And in order to do that, you have to decide on how to randomize the selection of validators. And in order to do that, you have to have a random oracle, and all of these things became one big bundle. It was also evident that this couldn't be done simply as a series of incremental changes on Ethereum 1. And so then a very big decision was made, which was a clean slate design. Stop trying to figure out how to incrementally move Ethereum 1 closer, and instead make the decision that Ethereum 1 will simply be swallowed by Ethereum 2 as a state snapshot in a single shard sometime in the future, and then be able to start Ethereum 2 design with a completely clean slate without worrying about how to incrementally change Ethereum 1 with backwards compatibility. Meaning that the perennial problem in technology, especially in the technology of live, real-time production blockchains, which is how do you do engine maintenance on the aircraft while flying, was solved in Ethereum with the following formulation. We will build a whole other bigger plane on the ground, and we will launch it from the ground and have it fly in formation with our current plane without making any changes to the current plane. And then we will open the rear bay doors of our new plane, and we will park the entire Ethereum 1 plane in the belly of Ethereum 2 when we're good and ready. And that means it's going to take longer. Instead of making just one change to proof of stake, it was several changes. And instead of making those changes to Ethereum 1, it was decided to launch a clean slate design, which released a lot of the dependencies and constraints and allowed the researchers to look at the broader picture, both the broader picture of sharding, coordination between chains, atomicity and synchronization of state for contracts across chains, which is a very big problem, moving to a new virtual machine architecture, and doing proof of stake all at the same time with a transition plan. And of course, yes, it took an extra 3 years of research to get there, and now it's going to take 2 years of deployment. One of the other key things here is to understand that premature trade-off design decisions and optimizations are very damaging, meaning that it's better to say, we don't know exactly how the cross-chain synchronization is going to happen. We don't know exactly how and whether the EVM is going to move to WebAssembly. We don't know exactly how, when, and whether we're going to have execution environments in separate shards or maybe as virtual environments that cross shards. Those decisions are not going to be made now because it's not necessary to make them now and there's still active research happening. So instead, the phases are rolled out when they're ready. As each phase is ready, it solidifies some of the decisions for the future without solidifying too many of the decisions and sending the entire protocol design down a one-way path that may end up being a dead end. This is a very deliberate design methodology. And you see this in software engineering a lot. It's very, very dangerous to do premature optimization where you make design trade-offs today that close a potential path or innovation in the future when you don't have all of the information. And so that's why it's taken so long. That's why it's being done as a roadmap. All right, I think this is a good time for us to take a break. We're going to take a little break now. I'm going to keep you on your seats because what I'm going to do is right after the break, I'm going to come back and I'm going to do a down the rabbit hole section where I'm going to tell you about the roadmap of deployment of ETH 2.0, what happens, when it happens, how it works with everything else that is happening, what to expect next, what we know and what we don't know. And I'm going to answer all of that in one segment which we call Down the Rabbit Hole, which I know you all love. But first, I'm going to nag you and tell you about all of the wonderful supporters who make it possible for me to do this work. So you're going to watch some advertising. How annoying. And then we'll be right back. If you really don't want to watch this, of course, you can mute and jump in the chat. But I would appreciate if you took a moment to see why it is possible for me to do this work and give education for free, ad-free, with a whole team of people, without sponsors, without endorsements, and without bias, with as neutral a perspective as possible through the support of my community builders on Patreon and on YouTube and other platforms with donations. Let's hear it from them.
I am a patron of Andreas because I came across his videos online and that's how I learned about Bitcoin, so that's how I got introduced to Bitcoin.
I'm out tonight at a social event organised by Andreas as part of his Patreon support. We just had a few drinks in a pub, which is a Punch Tavern, downtown London, so it's been a really fun evening to meet a lot of like-minded people.
We should support the work Andreas is doing. He's doing so much in getting new people into Bitcoin and into Bitcoin education.
He's a great teacher. He can explain very complex topics in an easy to understand way. He's very honest, very precise, technically prepared, and intellectually honest. I think is his best characteristic.
Brings such clarity to really complex subjects, which is Bitcoin, and the industry around it.
It has been a very, very good inspiration for me. And every Bitcoin I'm giving to him, it will be very well used in helping others understand Bitcoin, and I think it will improve the world at some point.
Being a patron, I get to meet Andreas, and that's why I love being a patron. I'm going to continue being a patron.
I think it's just a good thing if you're interested in learning new things and also want to support the Bitcoin community, then you got to be a patron.
Being a Patreon makes you feel special. You can attend to his live Q&A sessions. You can meet him at happy hours. It's really great, totally worth it. I'm very, very enthusiastic of being a Patreon.
I'd like him to be able to produce his great and valuable content in the future free from advertising and just with the help of his Patreons, and that's why I'm supporting him on Patreon.
If you enjoyed this video, please subscribe, like, and share.
Enough of that. Okay, you heard it. So I hope I didn't bore you too much with that, but thank you for me and for my entire team for all of your support, your kind words, your contributions, and of course your participation in these live streams and asking me fantastic questions. So it's time for Down the Rabbit Hole, the section where I ask myself the question that was formulated perfectly by myself, and I'm going to answer it. Thump. All right, this is the Down the Rabbit Hole segment, and I'm going to talk a bit about the Ethereum 2.0 roadmap. What happens, when it happens, and how it will affect you. Now, we have a lot of clarity for phases 0, 1, and 1.5. We have less clarity for phase 2. So we'll talk a bit about how these things roll out. So, phase 0. Phase 0 is the beacon chain. It's about to launch in November, and it is currently operating as a testnet called Medasha, Spadina in a week or so. And phase 0 operates the beacon chain, which produces a set of validators for each block and allows you to stake 32 Ether. That's the minimum stake you need in order to participate as a validator. And once you have staked 32 Ether, you may be selected by the randomness function to validate the beacon chain at a specific height. Now, at this point, this is a hybrid proof of work, proof of stake, meaning that Ethereum 1's stake, Ethereum 1's chain isn't involved. It's just the beacon chain that is being staked against. So this is a coordination chain, and at that moment, there are no smart contracts running on this. But there is a one-way function that, as far as I understand it, will allow you to take Ether from your ETH1 chain. And by making a transaction that submits it to a smart contract, you can then essentially wormhole it, magically transport it into Ethereum 2.0. So basically that smart contract on the Ethereum 1 chain packages up your Ether, locks it, and then releases an equivalent amount of Ether in the beacon chain so you can start validating. And you use that as your stake. After phase 0 comes phase 1. Phase 1 is the deployment of 64 shards and the beginning of cross-shard synchronization. And this happens with, I believe they're called crosslinks. So basically what happens here is that validators are now validating on a specific shard, and they're also synchronizing between that shard and the beacon chain. So validators are now validating the shards, producing the roll-up state of the shard that is then committed to the beacon chain and allows synchronization between the shards and the beacon chain. Think of this now as 64 sharded blockchains running in parallel. Theoretically, each one has the same capacity as the current ETH1 chain in terms of transaction capacity. So this will allow scaling by a factor of 64 on Ethereum. 64 times more transactions, executions, smart contracts, data, etc. This is going to produce a lot of data, but the validators will be validating one shard at a time. So essentially, it's a parallelization process. In phase 1.5, and this is a critical moment, the entire ETH1 chain gets airlifted into ETH2 and becomes one of the 64 shards. So one of the 64 shards takes a snapshot of the entire ETH1 chain and becomes the live chain. So essentially what happens at that point is if you were operating a dApp, a smart contract, or had money in your account on Ethereum 1, nothing changes. You continue to use it in exactly the same way, but the big difference is that Ethereum 1 is no longer being validated by proof-of-work mining. It is now a chain that is validated as one of the shards and synchronized into the beacon chain with a proof-of-stake mechanism that occurs entirely inside Ethereum 2.0. And by phase 2, you have a number of transitions, and phase 2 is the most vague element at the moment, whereby other shards are activated. dApps can be deployed and have to select which shards they're deployed on, and cross-shard synchronization and the ability to do composability across shards, which is still a big open research question as to exactly how that will work, and of course is often criticized because it is not clear in its details how it will work and what types of attacks it might create. And also at that point, there's the possibility of a couple of other features being wrapped up in phase 2, including the transition to WebAssembly for certain shards. Maybe some shards run EVM, maybe some shards run EWASM, maybe all shards run EWASM, and Ethereum 1.0 transitions to EWASM, gets cross-compiled essentially, so that the contracts run on EWASM. That's not yet clear. And then there's also the possibility of stateless Ethereum as well as execution environments, which are a couple of other little wrinkles or innovations, depending on how you look at them, that may be deployed as part of phase 2. There may be more phases. There may be a phase 2.5, a phase 3. That roadmap is not clear that far. Let's see if there are any follow-up questions, and if not, this is our Down the Rabbit Hole. EWASM, by the way, stands for Ethereum Web Assembly. So WASM, EWASM. I think it stands for that. I might be wrong. The acronym might mean something different. That's what I remember it as. All right, that does it. That was one more edition of Down the Rabbit Hole, and with that, we have come to the end of this live stream. This is still early days. We're going to be doing a lot more work and talking about Ethereum 2. Now, I did notice, you know, there are always people who are upset, either because I do talk about the technology that I clearly shouldn't be talking about because it's heresy, or because I don't talk about other technologies. This is a common phenomenon. I like apples. Why do you hate oranges? Why do you only talk about apples? Oranges are so much better. Listen, this is a full-time job just keeping up with these technologies. I do not have the time to invest into researching every blockchain out there. And there is a threshold of research required to have what is known as a well-formed, informed opinion on a topic. I could just spout bullshit and not have an informed opinion. Lots of other pundits can do that for you, not me. It actually took me more than 3 years of research before I started expressing even a glimmer of an opinion on Ethereum. So don't ask me why I didn't mention Cardano or other technologies that you're looking at now, whether they have proof of stake or different proof of stake systems, or they deployed it before Ethereum or whatever. It's not because I don't like it or because I don't think it's valid or any of that. It's simply because I do not have an informed opinion. And the reason I don't have an informed opinion on those other chains is because I do not have the time to create an informed opinion on so many different technologies. I could just lie to you, but I won't. I'm going to tell you, when I don't have an opinion, I don't have an opinion. That means I don't have a positive opinion. I don't have a negative opinion. I have no opinion whatsoever. Why? Because I don't understand it enough to give you an opinion. I can't compare it. I can't contrast it. I can't analyze it. I can't research it. There's only so many hours in the day. What do I have an opinion on? Ethereum 2.0. How well informed is that opinion? About this much right now. I'm still learning, reading, and trying to keep up. And it's moving very, very fast. I'm trying my best here. And of course, don't forget, I'm still working intensively and spending the vast majority of my time working on Bitcoin as well as the Lightning Network. I'm writing Mastering the Lightning Network right now. And that requires a lot of time, a lot of research, a lot of reading, a lot of analysis, a lot of coding. I can only do so much in a day. So that's your answer to why I'm not talking about whatever your pet project is right now. Tomorrow, we have a VR happy hour for patrons. If you're a patron, you can join me in Altspace VR. We're going to be doing a meetup where we meet in VR with ridiculous avatars and we wave our virtual arms around and we have fun conversations about life, the universe, and the number 42. We have fun, we listen to music. We often have one of the patrons, Burst Up, playing a DJ set for us. Thank you again, Burst Up. It's a lot of fun. It's a great opportunity to just hang out and enjoy having a conversation with people who have similar interests. Next week is the September monthly open topic live stream. Live Q&A with open questions on any topic you want, unlike the topic-specific bonus live stream we did today. Any topic you want. The Slido is already open for patrons. You can find the code by looking at the public posts on Patreon, so you can start asking questions now. And we're going to open those questions up to our live viewers. Well, first to our YouTube members a couple of hours before the live stream starts, and then to our live viewers at the moment we start the live stream, where you can all join. Again, it's going to be a public open live stream. You can ask questions, and I will be answering them. That's next Saturday. And that's all I have for you today. Thank you for spending your Saturday morning, afternoon, or evening with me. I always appreciate your time. Thank you for the fantastic questions. Thank you for your patience watching my silly little ad about my Patreon contributors. And once again, I am so grateful that you give me the opportunity to do this work. Have a great weekend. Bye-bye.